Welcome back, everybody. I'm putting together my schedule right now. Let me switch over to my desktop view here. I don't know how to do this anymore. So yeah, it's been a while. Let's go to a coffee shop. All right. So yeah, I know it's been a while. I don't know. I just got back on. I'm trying to. Oh, there it is. I'm trying to make my itinerary here, which I could have done before the show started, but I don't buy into the typical show structure. And also, I'm afraid if I did it beforehand, I would probably just not go online at all. I spend too much time thinking about it. All right, this is my little itinerary. Yeah, so I hope everybody's doing good. It's Friday. I've been done with my work, so I'm either gonna work on my device some more, which I've been working on this week, but I'll probably be testing it, so that's a better thing to do online rather than coding, which is what I mostly do when I work on it. But yeah, we can do a little lecture here too, a little knowledge bomb. What should we do today? You know what? We'll do it on crappy metaphors about the brain. There. And what else? We'll test the device out. Yeah, I guess that's it. And then I might play a game on or offline. I've been playing what do you call it? Crusader Kings lately, which has been really fun. It's very social game. You play as an individual. So, and then you're kind of in old feudal empire times, but it's actually really complicated because you have all these different title and inheritance systems, and anyway, so it's a fun game. Yeah, so yeah, I my schedule. Well, I don't really have a schedule. I don't know when the last time I was on. Yeah, I was streaming. Yeah, I was streaming with a friend, and then he just started dropping a bunch of personal information, so I kind of cut the stream and took it down, but I put some clips up, but that was the last time I streamed. That was like 2 weeks ago. And now I'm back on. Mostly to update anyone who cares about my my device stuff, I guess. I don't know. Like I said, I'm kind of working alone on this, so it's kind of treating my multi-stream audience like a what do you call it? Board of directors or something. I clearly do not have the show genes in me. I don't have the panache for showmanship. So I don't know. I'm treating this more like people I'd be hanging out with. All right, so yeah, knowledge bomb time. Let me. I still have my splash screens. Let me flip over to one of my splash screens here. All right. So we're going to today be doing a thing on crappy metaphors about the brain. So basically, if you don't care about like technical words and concepts about the brain, I'm going to. I recently had to explain this to somebody who doesn't have that great of an attention span for like scientific things, so it kind of made me think that, oh, this might be a good way to explain things. But yeah, I don't know what happened to my old font. So yeah, as per usual, we'll keep this to like 5 minutes or something, really brief and quick. I don't know where my cool cursive font went. Ink free, what is this? That's pretty good. All right, brain equals computer. Everyone loves that metaphor, right? All right, so I'm gonna walk you through how I think about the brain computer. So actually I just got that computer back there, and I updated the LED lights on it. I had to take it apart, but now I have full control of my LED lights. I can do all kinds of cool patterns and stuff. Let's put it back to all blue. Let's do that. Yeah, so brain equals computer. Yeah, so I'm just gonna go through the different parts of the brain, like 4 or 5 parts, not hundreds, but and then I'm gonna, because I've been working on my device, and you know these. So my EEG device, which reads neural metrics, and I've been trying to think of sort of interpretable, understandable things for this. Anyway, so if you're familiar with a computer, if you're familiar as a motherboard, a CPU, a GPU, some RAM, and hard drives, right? I don't know how familiar you guys are with computers, whether or not you've built them before, or you've just vaguely aware enough of them, or you've had to fix them or whatever. So there is some metaphorical translation to a brains. So in a lot of ways, let me go ahead and start using colors here. The back of the brain is kind of like the GPU, because what it does is it processes vision. So it's processing all these 2D images coming from your brain, and I've drawn this before, but let's go ahead and draw like 2 big old eyeballs, big old vision cameras, and then you got big old fiber optic HDMI cables going to the back of your brain, right? So that part, so the visual cortex, like if you've taken neuroscience classes, you know, they love talking about V4, V5, because we've really characterized those. But all the V, you know, the layers, they just have numbers to them up to V6, and then they go to different areas. So it's kind of like a big GPU, right? And then you have the front of the brain, which is sort of where your executive control is. They like to say in cognitive neuroscientists. Wow, I really don't like that line. Where's my drawing pencil? There we go. So this is, you know, prefrontal control, which is like if you focus on something or pay attention to something a lot, you can pick up a lot of activity there. This is, you know, something that they study a lot with people with attention disorders. The prefrontal cortex is kind of where you set your goals moment to moment, and it kind of directs the rest of your brain. So in a lot of ways, it's like your CPU, because it directs everything else, and it tends to be like serially bottlenecked, like you can only process one thing at a time. And then in your temporal centers, which you have these temporal lobes, they're called, which is what this over here is. You have your hippocampi, and you can break down the hippocampi a bunch of different ways, but basically if you lose your hippocampi, you can't form new memories. So it's kind of like your distributed hardware system. So for memory access and memory writing and coding, that's kind of like your hard drives. So you got your CPU, you got your hard drives, you got your GPU, and then if you want to get a little fancier, these layers like in the parietal areas that follow the occipital areas are kind of like they're kind of like neural network software. They're like object recognition software. So, just because you have a computer with GPUs and everything, like the thing that allows you to hook up a camera to it and recognize, I don't know, people walking. I don't know if you've ever seen these things. People are using like visual recognition neural networks and things like that to hook up to security cameras so you can automatically detect, people versus cars versus other objects. So that kind of software that runs on top of all this hardware, it's kind of like your parietal stuff. That's where you have more complex object recognition. So there's some signals that you can get off that too. So that's it. That's where the metaphor kind of ends. These things are more distributed in the brain. They're not as concentrated in as they are in a computer. But it's kind of interesting because like what I'm working with. Let me use a different color. I'm just going to wrap this up by telling you why any of this is relevant. You can get signals off of all these things, kind of in this order that I'm drawing, so that when you see something new, let me pick a different color. Seeing something new over here. Yeah, like that. The event happens here. Oops. I need a bigger space. Let me see if I can make this bigger. This is kind of ridiculous. I always have this problem. All right. All right, so yeah, the event happens here, which is this event up here. And then following that in time, you start getting signals. About 100 milliseconds, it hits the back of your brain and you're getting early processing of it, depending on how much attention is being deployed by this, but doesn't matter. This kind of controls everything. So anyway, but whether or not this is basically online or really active, you see signals here, and then about 200 milliseconds you start seeing signals here. About 300 milliseconds you start seeing signals here, which is whether or not you're going to have an actual response to it. So if you have a task where you actually have to push a button or something like that, or pay attention to certain things and ignore other things, you might see that recognition of, say, a goal-oriented stimuli about 300 milliseconds. And then way later at like 500-600 milliseconds, you might see memory access, memory encoding. So this all happens at about, oh, it's off the screen. This all happens at about 600 milliseconds. And you can detect that with electrical sensors. So that's it. I just thought that'd be our little knowledge bomb, knowledge warhead lecture today. It's just something I've been thinking about because I've been trying to I've been trying to increase the signal processing on my device, but then I've also been trying to think really hard about like what do I personally want to see for this thing to be like fun and useful and sort of meaningful. So you kind of have to think hard about what these signals are and what they mean. So I don't know, the metaphor, as silly as it is, and I don't know, more relatable metaphors I think can be very good sometimes, but a lot of times in like science land, or people trying to like out serious each other, they they tend to be kind of negative about those kind of easy to digest metaphors, but I think it works pretty well. Especially, there's a lot of people who are familiar with computers in this day and age, or built them, or whatever. So I haven't streamed in a while, so let me make sure everything is working over here. Just give me a second. And then the next thing we're probably going to do is I'm probably just going to put the device on and load it up. I did make like a user-facing GUI for it, so I actually have something to show you, not just horrible code. This is, sorry everyone, give me a second here. Okay, well, I just assume everything's working. Okay, yeah, I don't know. Okay, so let me throw this device on and boot it up, and I don't know, show you what's working so far. I did see the what's the guy, the Valve guy, wearing one of these, because this is open source hardware. I saw him wearing one of these in some news article. It was really annoying. I really shouldn't talk about it because I'll probably rant about it and get negative, but I don't know. It was, oh yeah, let me see if I should have turned it on before. Oh wow, that causes interference in my earphones. That's kind of funny. I hear this real buzzing when I turn it on. Okay, well, hopefully that's not in something you guys can hear. Okay, I gotta take this back off because I can't see if it's on or not. I usually use my camera to. It's not on. Oh, there he goes. Yeah, I replaced the wires, but they're still kind of loose. I don't know. It's a really minor fix, but the wires are kind of loose, so the power goes in and out sometimes. Yeah, so this is like open source hardware that they sell, but the problem is, I mean, nobody can do anything useful with it, which obviously annoys me because I've put in like, I don't even know at this point, like 1,000 hours into trying to make it useful. But okay, so, and the thing I do is I put on eye tracking too. Oh yeah, and I fixed the shields on these things so that it doesn't interfere with my head tracking camera. All right, this is going to take me a second to boot everything up. This cord is too tight. Okay, yeah, there's my eyeball camera, so I'll just move them on screen. Wait, one of them has, oh, there's something in the camera. That's weird. This is why I don't do anything on camera anymore. Oh yeah, it's getting dark in here too. All right, let me open up my EEG software. Put on my FFT plots. Put on my head plots to make sure all the channels are. Although I usually just eyeball it, everything is under like 100 or 50. So everything's in, it's all in context. Sometimes I have like a floating one. So I just use this software to check it. I eventually can code something to tell me that, you know, one of them's not in contact with my skin or head. Because I have a lot of hair. I should probably shave my head, but I don't know. It's more challenging this way, so I don't know. Oh yeah. Oh yeah, this is gonna be stupid if I have to take this back off, but I think I might. All right, I will be back in a second. This is super easy, super convenient. If you do buy the open source hardware, it is wireless. That's how they sell it. But I found it very annoying because you have to wear a battery on your head, and I end up putting a very big battery on, and it's kind of heavy on your head, heavier than this thing. This thing actually is not that heavy. It looks probably, but it's just all light plastic. But with the battery, you know, you can kind of feel it. It kind of drags, depending where you put it, on one side or the other, and then it runs out of power all the time. So I wasn't a fan of it. But here we go. All right, I gotta pull up the software again to recheck it. And then I gotta fix the eye tracking situation here. All right, we do this again. All right, everything looks good. Unless I disconnected it. Oh no, one of them's floating. Number 4 is floating. Let me put my head plot on. Which is number 4? 4 is the right middle one. Something's poking. Yeah, this is not exactly consumer ready yet. Oh, it's this guy. All right, 5 and 6. Oh, 5 and 6 are these back ones. Oh, there's just too much hair. Yeah, their software is a little jumpy, but there it goes. Okay, so they're all in contact. All right, let me close that out. And then my eye tracking thing, there was, oh, I see. It's just some tape got off. No, it's this one, right? Oh, it's this. All right, super smooth. All right, there you go. Put my earphone back in so I can track the audio. I don't usually have earphones on. It's just when I stream, because I don't know how else to track the audio without playing it out loud and then getting feedback. So, oh, these cords are all tangled up. Just gonna unplug this. All right, let's see if it reconnects here. There it goes. All right, so then the other thing I have to do is fire up Python. I have to fire up Python and then fire up my code. Here we go. My horrible 10 pages of code. So I haven't looked at this in a while, but I mean, I was working on it up until like 5-6 days ago, and there it goes. This is my little pop-out window, and let me make this bigger. Yeah, so I was working on this a few days ago, and it doesn't really matter. I just I stopped working on it. I started working on like more the signal processing side again, but hopefully this works. I was trying to run some optimizations. Doesn't matter. I have a lot of data, so I can run. Oh, I never updated my screen. There it goes. Okay, there it goes. Cool. So yeah, I have this working live now. So every 10 seconds it updates. So these are, in theory, ERPs, which we talked about whenever I was last on, like 3 weeks ago or something. Oh yeah, that's a really bad one. Okay. Yeah, so in theory I'm trying to extract, there's just a lot of noise in that one. I actually never seen it do that before. In theory, it's tracking my eyeballs, seeing every time I move my eyes, and then extracting events. What's going on? Is it frozen? Oh, it's totally frozen. What's going on? Huh. All right. It's not what do you call it? Commercial grade code, you know? It's my code, so I didn't go to school for software engineering, so you know. All right. It usually works better than this though. Give me a second. This window does not update very well because it's this. I use Pygame, which is a library you can use in Python. There it goes. Okay. Yeah, and so now it's gonna record. It's doing all the signal processing. It's doing all this modeling, extraction, and about every 10 seconds it should update. And you know, it tracks my eyeballs, tracks my head movement, tries to remove all those sources of noise, and extracts these measures. We'll see how it actually looks. And then added history plot. So once we get past the first 10 seconds, it'll start tracking my history. Once we get a few data points, I'll go into this a little more. I just want to make sure this is working. I've been messing with the parameters, trying to make it more sensitive, but not sure why it crashed. Yeah, so there's a lot on the screen, but it's because I'm using it to debug it or whatever. So on the bottom is really simple. Actually, it's just more your classic alpha, theta waves, and then I added delta and beta just because those can be seen with this level of hardware too. So I'm just looking at it to see if anything is looks interesting or looks accurate. So in theory, what I do next is like run this for a little while I do different types of activities. So I could I don't know, I could do something really controlled and sit down and take like a math test or something and see how my processing and stuff like that is, and then watch like a movie that I've seen before versus watch a movie I haven't seen before. These are like conditions I could do. But yeah, so it looks. Yeah, and I have the fit value of the model and the number of ERPs extracted reported on there, which is really just how many times I move my eyes and then extracting events based off that. So yeah, the red one is the top one here. I don't know if you guys can see that. I'm gonna blow this up. Let me blow this up. There. So the red one is sort of the visual processing, which is this. Oh yeah, you can't see that. Okay. Yeah, so this first peak, is it gonna crash now? Oh my god. Yeah, that's cool. No, don't report it to Windows. I don't understand why they ask you to report it to Windows. It's not like Windows is gonna do anything. Like, I understand it's debugging information for them, but does their database really need things people coded in Python? Okay, cool. Well, I'm torturing myself and probably torturing anybody else watching this, so this is great. It's good. Yeah. Here, let me try this one more time, and then I'll probably close it all down and set it on fire, because this stuff does not behave well. You know what we should all do? We should just have kids, have them have grandkids, and have them have grandkids, and maybe by then this stuff will work, and meanwhile we should just all chill. I don't understand what's going on. Is my eye tracker disconnected? Oh, you know what? My EEG is probably disconnected. It's because it's this cord. I thought I fixed it, but there's I literally replaced all these pieces of the cord I could find that were broken or whatever. They were like not reliable, and apparently I missed a piece or something because it's still loose. Okay, so it's connecting. I'm just gonna check all the channels again. It's fine. All right, so let's start my program up. All right, so basically this this early peak here, I don't know if you can see, there's, it doesn't matter, but it's you know, it's called the P100, and that's what we're getting for the visual processing. Then in order, just like we did in our kind of lecture here, the N200, which is kind of like object recognition, you know, people who are doing search tasks or identification tasks. Yeah, I don't know what's going on. This thing is not behaving today. So, yeah, that's it. Okay. It's on. I don't know what's going on. Okay, cool. Yeah, a lot of wires, a lot of debugging problems. Anyway, in theory, you know, you could get like a, it's kind of like a, you know, Apple Watch, which I don't even own an Apple Watch or a Fitbit or anything like that, but it's like you could get one for your brain and you could track yourself and maybe get insights, you know, on your like mental energy or your ability to adapt or learn or whatever. Yeah. Anyway, yeah, so I guess I'll just use the frozen one. But yeah, basically then the third one is sort of, I just call it the brain processing. It's kind of your decision and action, which is P300. And then there's like an N400, which doesn't really change that much from most sort of scientific manipulations. And there's something called P600, which is this late 600 millisecond thing that's kind of correlates with memory access, you know, so if you're encoding something or recalling something, and that's kind of where I've pulled these metrics from. Let me go ahead and finish off this plot. I've talked about this stuff before. Let me transition to the bottom of this. Then on the bottom here, delta is sort of probably the least studied because it's mostly correlated with deep sleep, but I just captured it. I don't see it changing very much actually. Then you have a theta, which is the next one. So delta is like the slowest wave, and again it's like REM sleep. Theta is more prefrontal, although you can see it in other areas of your brain, and it mostly correlates with like cognitive effort, I guess is a good way to say it. Oh yeah, that's what I wrote, cognitive effort. And then alpha is usually they see it in the back of the brain, and usually like if you buy an open source EEG headset, you can look at alpha. But yeah, alpha is just like the inhibition of cortical activity. So it's kind of like when you're more internally reflective, and then beta is just activity that often you see over like your motor cortex or wherever you're looking. So, but often they're studying beta in the context of people about to do an action or doing an action. So anyway, that's it. Cool. Well, that ends my experimental disaster for today. Thanks for watching. And if you're watching, if you watch it later, I don't know, leave your pointers or comments somewhere where I can read it. I don't know where that would be. Maybe on my Twitter or something. I don't know. Thanks, everybody. Have a nice day.